Hello viewers, in today's class we are going to uh, learn how to find the derivative of a function involving logarithms, but the base is different from e, right? We know that if y is equal to log x to the base e, then this is known as a natural log, right? So this is called natural logarithm, right? And if we have y is equal to log of x, say the base is 10, then this is called common logarithms, right? Common logarithm. So we have here two types of log. It means when we have the base e, then it is called natural logarithms. When we have base 10, it is called common logarithms, right? So here we have already learned that the derivative of log x when the base is e, right, it is 1 over x, right? Now what about the derivative of this function when the base is other than e, right? So here we have to differentiate log x to the base 10, right? So we know that the derivative of log x to the base e is simply 1 over x, but here if the base is changed to some other number, and here we have say 10, then the derivative of log x to the base 10 cannot be simply 1 over x, right? So what we will do here, so here we'll make use of the base changing formula, right? The base changing formula. So the base changing formula is given by log of p to the base a can be written as log of p to the base say b divided by log of a to the base b, right? So this is the base changing formula. Now it means here we have the log of p to the base a, right? So the initial base was a, and we have changed this base a to the base b, here b, and here we have also b, right? So log p to the base a can be written as log p divided by log a to the same base b, right? So let us write log 10x, right, with the help of this base changing formula. So log 10x. So here for p we have x and for a we have 10. Now we wish to change this base 10, right, to e. So we want to change the base 10 to the base e. So what we will do, so here we'll write log e divided by log e. So we have changed this base 10 to the base e, and here we'll write x and here we'll write 10. So with the help of this rule, that is log 10x, we can write log ex divided by log e 10. So here we can now write d over dx of log x to the base e divided by log 10 to the base e, right? Now this is a constant, so now we can take it outside this as the derivative operator. So we can write it as 1 over log 10 to the base e, and the derivative of log x to the base e. So now we know that the derivative of log x to the base e is 1 over x. So this is 1 over log 10 to the base e times 1 over x. So the derivative of log x to the base 10 is given by 1 over x multiplied by 1 over log 10 to the base e. So with the help of this discussion, we arrive at the conclusion that whenever we have to find the derivative of log x to some base, say b, then we can simply write it as 1 over log b to the base e times 1 over x, right? Because here we have log x to the base 10, so here we have 1 over log 10 to the base e. So here the value of b is 10, and for x we have x, right? So suppose we have to find the derivative of say log of x to the base 7. So with the help of this base changing formula, we can write d over dx of log, changing this base to base of 7 to e, we can write log x to the base e divided by log 7 to the base e, and this is a constant, so we can take it outside. So 1 over log 7 to the base e, the derivative of log e x, and the derivative of log x to the base e is 1 over x, so we can write 1 over log 7 to the base e times 1 over x. So this is the derivative of log x to the base 7. So therefore we can now write some more examples here. Suppose we have to find the derivative of log say x to the base 6, then this can simply be written as 1 over log 6 to the base e times 1 over x, right? Now let us find the derivative of this function y, and it is given by a log of log x to the base say 7, right? So here what we will do, we'll write d over dx of log 7 log x, and applying this base changing formula, we can now write d over dx, and taking this 7 to the base e, so we can write log of log x to the base e divided by log of 7 to the base e. Now this is the constant, so taking log 7 to the base e outside, so we can write log 7 to the base e and the derivative of log x, right? So now this is 1 over log 7 to the base e, and the derivative of log x, because we know that the derivative of log x is 1 over x, so this is simply 1 over log x, and then by chain rule the derivative of log x is 1 over x. So this is the required derivative of this function.